For class, I went on to Google and I just Googled chain rule worksheet because I like to do problems I haven't done before. So let's do some problems. And we won't do all these, but we'll do some of them. All right, how about, yeah, something like this. Negative 5x to the 4th minus 3 all to the 7th power. That's a 7. 7th, oh gosh. 7th power. All right, Grant. Do you see an inner and an outer? Yes? What's your inner? Okay, that's my inner. Outer? 7th power, right? Something, so the outer is actually like a power function. It's raising something to the 7th power.
Is it okay to look at the outer as x to the 7th?
Yes, x, you can look at, exactly that's the way you want to look at it. But I'm going to do it this way. I'm looking at the outer as my folder to the 7th. If you want to look at it as x to the 7th, that's fine, right? Just make sure that when you take derivative of it, you don't say 7x to the 6th. Because it's not 7x to the 6th, it's 7 folder to the 6th, right? Okay. Grant, I think I just gave it away, right? So we start out, we got this, right? So derivative of that would be? And then continue, chain rule. Negative 20x cubed, and that's it, right? Okay, and Grant, do I have to have parentheses here?
Yeah.
I only have one term, right? So I technically don't need the parentheses. What I have to have though is the dot. Because if you don't put the dot and you don't put parentheses, what does that look like I'm doing? Looks like I'm subtracting, right? So I'm not subtracting, I'm multiplying that. So here parentheses are kind of overkill, but they actually help you see that it is a product. Okay?
So to get the second prime on that one, you have to use product rule
And chain rule. Yeah, don't worry, we're headed there. But we you know, crawl before you walk, right? How about this? I'll make this one up. Right. Joaquin? Doing all right? No, you walked in a little late. So do you see composition of two functions? Do you see an inner function and an outer function? Outer function would be the square root, okay? So this root is the outer, and then the inner? All of this, right? That's your inner. Okay, good. So we always start out chain rule by taking the derivative of the outer or inner? Outer, right? So ready? Are you ready to go with this? I'll use my, what do you want? Use the bottle again? I'm going to cover the inner with the bottle. Okay, Joaquin, what is the derivative of the square root of a bottle? Yeah, you're on the right track. Close to that. So what is it? Y'all remember what's the derivative of the square root of something? 1 over 2 square root of x normally, right? But it's actually a bottle now, right? So the derivative of the square root of a bottle is 1 over 2 root bottle, right? But what's the bottle? It's this. And then we're not done, right? You want to keep going, Joaquin? What do I do now?
Then it will be 1 over all the inner function.
Yeah, the derivative of the inner function. And I multiply it, right? I'm multiplying this times
8x. Oh, yeah, 9x.
9x to the 8th Okay, do I need parentheses?
Yes.
Yes, I have two terms. There we go. That's it. Yes?
Could you have converted this?
You could have converted that to the 1/2 power. Yes, you could.
The 1/2.
And then did the 1/2 out. I'm going to do that on the next example. I think it's best for you to just remember the derivative of the square root of x is 1/2 root x. Just remember that, right? I gave it to you a while back. One more thing we could do here is we could take this entire thing and just slide it up on top. You could just put all of this on top of that and be done. On the test, it would be okay to leave it like that. Yes, on this test, but later on you'll have to do something with this algebraically. So, all right, how about this one? 1 over the cube root of sine x. Okay, let me ask for a volunteer, but someone who has not participated yet. Anyone want to volunteer? You're ready. Have you gone? No, you haven't. I haven't called on you, right?
No.
What's your last name again?
Ritter?
Okay, Ritter. There we go. David. Yes. All right, David. So, do you see composition? Do you see something inside of something?
Yes.
Okay, tell me what you see.
So I see that the sine x is inside of the cube root.
Cube root, okay.
I don't know if the 1 over the cube root is like the whole thing.
Yeah, so there's a little bit of an issue here, right? Because you see the cube root, you see the sign inside of it, but that's all in a denominator, isn't it?
Yes.
So maybe before we do anything, it might be worth it for us to do this first. Rewrite that using rational exponents, so make that 1/3 power. Is that all right, David? Everyone see that? And then, can't we bring that up?
Yes.
Okay, so what would that be if I brought it up?
Negative. So it would be sine x inside negative 1/3.
Negative 1/3 power, right?
Yes.
So all we've done is rewritten the problem, right? Y'all agree? We haven't done any sort of derivatives yet. But now I think it's more obvious that you have an inner and an outer, yes?
Yes.
Okay, so you want to go ahead and go with this?
So we do the outer first.
Okay. So what is the derivative of, let's just do my marker. What's the derivative of my marker to the negative 1/3 power?
So we do the power rule.
Power rule?
So we take it down out, right?
Yep, down, out. So what comes out front?
1 minus the 1/3, right?
That'll be our new
Oh,
power.
that'd be new power, so negative 1/3.
Negative 1/3 comes out. And then
Raised to the 1 minus,
all of that raised to the, you have to subtract 1 from that.
yes. Subtract.
So it's minus 4/3.
Yes,
Okay?
and then
So-
the sine x.
And then the sine x inside. Okay, so we rewrote the problem to make it look like something to a power so we could see an inner and an outer. We said derivative of the outer is a power rule. The power comes out, whatever was inside to the negative 4/3, we subtracted 1 from there, right? We're not done though, right, David? We still need to multiply by what?
The derivative of the inner,
Okay, which is
cosine.
cosine x. Right? Now, there's a lot of things we can do to this, all right? Let me write the way the answer would look in the back of the book, most likely. It would look like this. That's probably what it would look like in the back of the book. So what they did here is just put the negative with the cosine, put it on top. They dropped that to the bottom. If we drop it to the bottom, it's 1 over sine x to the positive 4/3. And then rewriting that from a rational exponent to a radical turns into this. So that problem required a little bit more work, right? Because you had to kind of manipulate it algebraically first, right? Are there any questions on that one?
What would it have looked like if you had done it in the original form?
Well, yeah, the question, that would be a good question. How would you? Really, There's not an easy way to do it just like this. Converting it to this and this is the way you want to go. Now, there is a way to handle when we have more than one composition, which is the next example I want to give you. Look at this one. What about the square root of tangent of x to the fourth plus 1? All right, this is our first problem like this. When you look at that problem, I hope you recognize that we have more than just an inner and an outer, right? We actually have like an inner, a middle, and an outer. It's actually a composition of three things. So what would be the inner one? X to the fourth plus 1, right? That's the inner one, right? If you plug x in, that's the first thing that happens. Then what happens? Tangent, right? That's another function. And then what happens? The square root. So how in the world do we do it when we have 3, right? So really, it's kind of like, do we have a formula when this is f of g, but instead of g, we've got another function, h, plugged into that, like a triple composition. Is there a formula for that? Well, I'm sure there is, but it gets very complicated if you start to write all these formulas out. So this is where the rag and the water bottle and all that stuff, I think, is more powerful if you understand this concept. So you always start with what? The outer. Okay, what's the outer here? The root. Okay. So always start with the root. All right, so I'm about to take derivative, all right, and I have the square root of that right there, that rag. The rag covers everything in there, right? So what's the derivative of the square root of a rag? 1 over 2 roots of the rag, right? What was the rag? All that, right? So I just stick that right in here. Tangent of x to the fourth plus 1. See, the whole thing, the whole rag is underneath that root, right? Now, I have done the derivative of the outer one, right? So I'm no longer concerned about looking at that. And now I'm kind of back to where I was a minute ago, where I only have a function inside of another one, right? So this is now the outer and this is the inner. And I'm going to cover up the inside with this, and I'm going to take derivative of tangent of an eraser. What's the derivative of tangent of something? Secant squared, right? So secant squared of the, so times secant squared of the eraser, x to the fourth plus 1, right? Now you've done the tangent. What comes next?
Times 4x.
Times the derivative of what's in there, so what is it?
4x cubed.
Just 4x cubed, and that's it, right? There's nothing else there. There's a little bit of cleaning up that can happen. That can go, right? And let me slide all that on top. I'm going to put the 2, the x cubed, in front of the secant squared of x to the fourth plus 1. All of that over the square root of tangent of 4x plus 1. There we go. There's our derivative. Any questions? Roberto?
I guess the algebra is kind of throwing me off.
Okay.
So that you,
I just reduced this fraction. I looked at it as like 4 divided by 2.
okay, so if it's multiplication, you can do that,
Yes, absolutely. If it's multiplication, you can.
but not when it's addition.
That's right. If it's addition, you cannot. All right.
You moved the last x cubed in the front with the 2. Yeah, 2x. And the x cubed.
Yeah, I moved this 4 went away and became a 2, right? Yes? And then I just move that in front of the secant squared. That's just by convention. We like to put these in front of trig functions. You could have left it at the end. All right. Let's see here. How about this one? Cosine, cosine, cosine of x. Cosine of cosine of cosine of x. Do you see a function plugged into a function?
Yep.
What do you see?
Like
Cosine x being plugged into cosine,
plug into
cosine again, right? So inner, right? Middle, outer, kind of? Where do we always start? Outer. All right. So it's going to be, what's the derivative? Let me put my arm up here. What's the derivative of cosine of my arm? Negative sine, right?
Oh yeah,
Negative sine of what?
the cosine
Of my arm, right? Which was what? Cosine of x. All that is the derivative of the outer one. I now need, I've done this one. I now need to multiply that times the derivative of the next layer. It's kind of like onion, right? You start with the outer layer and work your way in. So now I'll put my little rag here. I have cosine of my rag, right? I'm trying to take derivative of that. So what's derivative of cosine of my rag?
negative sine
So times negative sine of what?
cosine.
Yeah, cosine of x. Now I've done this one. One more. Go inside, take derivative of cosine, you get negative sine of x. All right, we have a bunch of multiplications here, right? Multiply, multiply. And so you have a negative, right? A negative times a negative times a negative. So that should be negative still. So negative, and then I'm just going to write everything. You cannot put any of that together, right? This is negative because there were three negatives, so the whole thing's negative. Sine of cosine of x, and then times sine of cosine of x, and then times sine of x. Let's go to Desmos and see, just curious what cosine of x, or cosine of x looks like. Oh, it's actually kind of boring, isn't it? Not as interesting as I hoped it would be. All right, I just wanted to see it, that's all. Y'all feel like y'all are getting a little bit of the idea here?
Yeah.
Yeah? Well, we're going to just kind of ease our way into these. But I do want to maybe give you something to practice. How about we give you a few to practice, or maybe one or two to practice? Yeah, let me just give you a couple to practice here. I'm just going to make them up. I'll put two problems up here. All right, how about this? Y is cosine to the fifth of x squared plus 1. And the next one, y equals, what was I going to do? Start working on that. I'm going to think about what I want for the other one. All right, that's a harder one. All right, work on those. You can work together. Let me give you a few minutes. All right. First one, I think you can crank out. You know, the second one I think is going to require a little bit of thought. Right. have a question on the first one? On the first one. Questions on the first one? I thought you had it.
Well, yes.
Oh, you move it out front?
When I move it up front, do I move
Yeah,
it
multiply.
back? Oh, okay.
Yep, negative 10x. You don't have to do that, but, you know, it's not a...
Is this one for the second one?
Um,
Because that's 1 plus.
it's looking right. Yeah, that's looking
I
right.
plugged in decimals and it looked the same.
Yeah, no, that looks good. Okay, let's talk about the first one. What I think you need to see here to be successful with this one is that this is really cosine of x squared plus 1, all of it raised to the 5th power. If you do it that way, then you can see that you have like an inner, a middle, and an outer. And then you start with the outer. And so you have something to the 5th power, right? Take the derivative of that, the 5 comes out. All of this, don't touch it, right? Leave it alone. To the 4th power. Just remember, you have to do the power rule, so make sure you put a 4 up there. Times, okay, you've done the 5th power. So now you have derivative of cosine of something, which is negative sine of that something, right? Okay, now you've done the cosine. Now go inside there, take derivative of x squared, and you get 2x. There it is. That's the raw derivative. Now, cleaning things up, you can bring the 2x out in front with the 5, make it a 10x, and then take that negative and push it out front as well. So a more cleaned up version of this would be negative 10x cosine x squared plus 1 times sine of x squared plus 1. Where did I forgot the 4th. Yes, I did. So I meant put it right there. Take that 4th power and just push it back here. Same notation, or that notation means the same thing. All right, that's that one. This one is tricky. And look, there's more than one way to do this one, but here's the way I think is the cleanest, easiest way, and that is to try and rewrite it first. Don't try a derivative yet. Just try and rewrite it. Let's write it like this first. Okay? Right? Is that the same? That's what 1 over x means, right? X to the negative 1. And then I'm going to rewrite this as 1 plus x to the negative 1 all to the negative 1, because I can take this whole denominator and bring the whole thing up and just raise it to the negative 1. And that creates, right? This right here creates this fraction. Do y'all see how I did that? And when we look at it this way, we have an inner function, which when I look at it, I feel comfortable about taking its derivative, right? Could you take derivative of that? Could you take the derivative of that? Derivative of each one, right? And then can you take derivative of something to the negative 1? I hope so. So inner, outer, right? Inner, outer. I'm giving you a moment. If you did not do that, take a moment now, see if you can get that. And then I'll call on somebody. See if you got it. All right. How about Christopher? Who's Christopher? 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 No, Christopher? Nicholas. Nicholas? No? Alana? Yes? You ready?
Oh, yeah.
Did you- did you-
I thought you were doing attendance.
No. On this one, did you get this one? Here, present. No, on this one, did you get this one yet? Okay, so tell me kind of what you got here.
Negative in parentheses 1 plus x to the negative 1 and into parentheses to negative 2
Good.
times negative x to the negative 2.
All right, what do y'all think? Agree? Disagree? Agree? Good. Negative 1 came out. All of this, subtract 1 from that power becomes negative 2. Take derivative of what's inside. Derivative of 1? 0 plus derivative of this.
Negative.
Again, bring the negative 1 out, x to the negative 2. That's it. Now, that is an okay answer, but let's at least, if we're going to do anything, let's at least make these two negatives a positive, right? And then let's just drop them both down. That's what that is, right? Do y'all agree that's what that is?
For the square.
Oh, I forgot the squared. Sorry, thank you. This is squared, right?
Can you do 1 over x?
Yeah, okay, now you want me to change that to 1 over x? We all agree with that? That's pretty clean. Can we go even better? How about this? Can we do this? Put it together. Is this not the same as 1 plus 1 over x times x, all of that to the second power? Is that not the same thing? Aren't these both squared? So couldn't you just put these both next to each other and then just square them? You say no? You don't, no? Why not?
Don't you add them?
Do you agree with this? If I have two things multiplied together and I raise it to the n power, that I can apply the n power to both of them,
Oh, yeah, that's you do that.
right? Can't I do that? So if two different bases, same power, I can put them together to that power. That's exactly what I did here. I have a squared, and then this is the multiplication down here because it's multiplied, times b squared, so I can make that a times b squared. Right? Yes?
On that one, I was able to see that, so I multiplied it by x over x, and then use quotient.
Yeah, so what I'm about to show you is look at how nice our answer is going to be. Look, what can I do now? Distribute the x through, right? And what do we get? 1 over x plus 1, all of that squared. That's a pretty clean answer, isn't it? That's a pretty clean answer. So when I started this problem, I said there's several ways to do this, right? Didn't I? And one suggestion, what was your name again? I'm sorry. Grant. Grant did this. Grant said, you know, I don't like your way. And you decided to do what?
Multiplied by x over x.
Multiplied the whole thing by x over x. Are you allowed to do that? Can you take anything and multiply by 1? Yes. Okay, now, why did you do that?
To get rid of the fraction.
You just didn't like this complex fraction, right? So you wanted to get rid of this fraction, so you said, I'm going to multiply by x, and it would go away. If we do that and distribute top and bottom, right? On the top you get x, on the bottom you get